Good evening everyone. Myself Ashwika. I am from ECE department. Today I am here to explain a topic on phase detectors or comparators in analog and digital IC applications. The subject code is 23508. Let's come to introduction. What is a phase detector or phase comparator? A phase detector or phase comparator is circuit that compares the phase of two input signals. It generates an output voltage proportional to the phase difference between inputs. Main purpose: detect phase error and correct it. The output voltage or current represents the phase difference between the signals. It converts phase difference into a DC voltage used to adjust the oscillator frequency. The output signal polarity indicates where the input leads or lags. It is a first stage in a phase lock loop, that is PLL system. A phase detector, also called a phase comparator, compares two waveforms, and the output of the phase detector is a representation of the phase difference of the signals. There are two basic types of phase detectors: sinusoidal phase detectors and square signal phase detectors, which operate either in binary mode or by detecting zero crossings. Here the block diagrams of phase detector. X of t is input, Y of t is output. One waveform. The block diagram of a phase detector is shown in figure A, with output Y of t is related to the difference of the phase of the input signals X of t. A square detector is based on a logic circuit producing a signal that is averaged or integrated over time. An example is the XOR gate shown in figure B, which compares two digital signals that here have the same frequency but are shifted in phase. The output of the XOR gate Y of t is also a pulse train, and the average value of Y of t is proportional to the phase difference of X of t and W of t. This average value can be obtained by passing Y of t through a low pass filter to obtain a DC value. If X of t and W of t have different but close frequencies, the output of low pass filter will be a slowly varying signal. This circuit could be used to detect the phase difference of analog signals, but the signals first need to be converted to digital signals. Sinusoidal phase detectors can use a mixer or an analog multiplier. The inputs could be two sinusoids with one of them adjusted in phase, either externally or within the detector itself. So consider the inputs to the phase detector to be X of t equal to Ax and Wx of t plus pi of x, and W of t equal to A omega cos omega Wt plus phi omega. Then the output of multiplier is y of t equal to A of x sin W of xt plus pi of x into AW cos Wt omega plus omega phi is equals to 1 of t Ax AW into sin Wxt plus Wt plus pi x plus pi W plus sin omega xt minus Wt plus pi of x minus pi of W. Here the frequency multipliers, that is input, non-linear element, tuning circuit, band pass filter. Here the diagram is non-linear frequency multiplier and resistive multiplier, tuned multiplier. Non-linear frequency multiplier. A non-linear frequency multiplier uses the non-linear characteristics of a device like a diode or transistor to generate output frequencies that are harmonics of the input signal. The input signal excites the non-linear element producing harmonics, that is 2f, 3f, 4f of the input frequency. A filter or tuning circuit then selects the desired harmonic as the output. Resistive multiplier. A resistive multiplier operates using resistor networks where the output voltage is the product of two input voltages. It performs analog voltage multiplication based on Ohm's and Kirchhoff law. Typically used in analog circuits for phase detection and modulation and mixing. Queuing multiplier. What is queuing multiplier? A queuing frequency multiplier used as a non-linear gauge along with the queuing LC circuit. The queuing circuit is adjusted to resonate at a specific harmonic frequency of the input. The unwanted harmonics are filtered out, leaving only the desired multiple of frequency. Thank you.